We're playing basketball. We love the basketball. We're playing basketball. We love the basketball. We're playing basketball. These teams are basketball.
What?
We're playing basketball. Basketball. Oh, okay. Now basketball is my favorite sport. I like the way they dribble up and down the court. I do so fits on the microphone. I like no interruption when the game is on. I like slam dunk to take me to the hoop. My favorite play is the alley-oop. I like the pick and roll. I like the give and go, and that's basketball. Bow wow, let's hit it. Hi, I'm Kevin. Hi, I'm Saran.
Hi, my name is Alex Seidler.
Hi, I'm Michelle.
This is the physics of basketball. We will teach you to dribble, spin the ball on your finger, and shoot scientifically.
Shooting involves Newton's third law, elastic collision, and gravity. Passing the ball involves potential energy, kinetic energy, and stored energy. Bounce pass involves elastic energy, like this, and spinning the ball involves circular motion. As stated before, shooting involves Newton's third law, elastic collision, and gravity. Newton's third law is, for every action there is an equal and opposite reaction. So when you're shooting the ball and it hits the backboard, that's the equal and opposite reaction. Elastic collision is m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. And gravity is 9.8 meters per second squared.
The ball defines gravity. Whatever goes up must come down. The Earth has a gravitational pull that the Moon does not have.
This is an elastic collision. I will now be explaining the physics of basketball and passing it to Dr. Bassett. This is potential energy. When the ball is not moving, it has a potential to move, but it's not moving. And this is also stored energy because I'm holding the ball and I'm the stored energy. Kinetic energy is when it's moving. Dr. Bassett's going to bounce it back to me, and that's also going to be kinetic energy because it's moving. The higher I'm holding the ball is the more potential energy it has. This is a maximum point of potential energy. Potential energy is Eg equals mgh, which is also mass times gravity times height. Potential energy is when the ball is not moving out of position. So if you're holding the ball before you throw it, that's potential energy. Kinetic energy is Ek equals 1/2 mv squared, also known as 1/2 times mass times velocity squared. Kinetic energy is when you throw the ball. So after it's potential energy, when the ball is moving, that's the kinetic energy. So when it's in the air, you have kinetic energy. Stored energy is F equals Kx, also known as a spring constant times the amount that the spring can be stretched. So when you're holding the ball, that's the stored energy with the potential energy because it has a lot of stored energy. Elastic collision is when two objects collide and bounce off each other. So a bounce pass, when it hits the ground and bounces to the next person, that's an elastic collision. As well as a bank shot, when it hits the backboard and bounces into the basket, it's also an elastic collision.
This is a bank shot.
When Alec threw the ball, this was kinetic energy. It hit the backboard and went into the basket. This was the bank shot. It is equal and opposite reaction, Newton's third law. This is Alec. He throws the ball and it hits the backboard and goes into the basket. And this is also an elastic collision. The ball on the finger. The ball will remain spinning because the force of the spin will balance the ball on the finger. Due to the spin of the force, it is the only way to balance the ball on the finger.
This is circular motion. The only way this ball will balance on my finger is if there's an outside force acting upon it. And in this case, it's the spin.
So the faster it spins, the easier it is to balance. As it slows down though, watch as it slows down, it'll become harder to balance. And I can't balance it on my finger, I just go like this. And no, I'm not flicking off the camera. This is a real life example of physics in basketball.
How close was Gordon Hayward to winning the NCAA championship game? To make a basketball shot, 3 variables have to work together: launch angle, release velocity, and aim. Hayward's 54-degree launch angle was good, but his release velocity of 28 miles an hour was just barely too strong. Only half a mile an hour less, and the ball rebounds, hits the middle of the inside of the rim, and has a chance. But Hayward's real problem was the x-axis, his aim. If he releases the ball with the same launch angle at only half a mile an hour slower, and the ball hits just 3 inches to the left on the backboard, Butler wins. From 46 feet, that 3-inch margin translates to changing the angle on the x-axis of his release by less than half a degree. That's less than the width of the tip of a shoelace. That's also less than the width of the cords of a basketball net, which Duke got to cut down. For Sports Science on ESPN, I'm John Brinkus.
I'm Dr. Bassett, and I'm real cool. I teach at North Broward Preparatory School. Physics is awesome. Physics is fun. Makes me feel like #1. Yo, word to your mother, quantum mechanics style. Woo!
It's a waste of space, man.
Saron, just stop it.
No, you can trim it out in
Okay,
the
just stop
thing.
it.
You're going to be doing that.
Yeah, you can do it on the phone. Just go.
This is the physics of basketball. It will teach you how to dribble, spin the ball on your finger, and shoot. Scientifically.
That was so perfect.
This is the physics of basketball. It will teach you how to shoot, dribble, and spin a ball on your finger.
Can you imagine if you put that
That should be in the bloopers, or you just bleep it out.
in? Yeah, that'd be funny.
Alright. Alright, go.
Alright. Elastic collision is when 2 objects bounce off each other. And, start it.